All right. Hello, hello, hello. Today we are going to talk about balancing chemical reactions. Specifically, we're going to discuss double replacement, single replacement, composition, and decomposition. I'm going to make a separate video for combustion reactions because they take a different process. Okay, so we're going to start with double replacement. You should have this worksheet. This is worksheet 4.5A. Okay, worksheet 4.5A. It should look pretty familiar because these are the exact same equations that you had for worksheet 4.4B when we did reaction types the other day. So these are the same reactions, but this time we're going to be figuring out what these coefficients are. Okay, so we're going to start with double replacement because double replacements tend to be easier. Okay, so the first double replacement, the one that I'm going to do with you in this video, is going to be reaction D. Okay, so we're going to go through reaction D. Now, the first thing you should always do when you're balancing a chemical reaction is put a 1, literally write a 1 in every blank. Okay, this is because, and some of you don't need to do this, but this is because people forget that, oh, there's already a 1 there. And then they go, oh, well, I need more, so I'm going to write a 1 because they think that a blank means 0. No, the blank is already an implied 1. You must write 1s on the quiz. Okay, generally, we don't write 1s when their coefficient is a 1, but you have to on the quiz. Why? Because most of the time, it's going to be a 1. And I'm not going to just give you free points for leaving it blank. If you just leave it blank, I'm not giving you the points. So you have to actually write 1s in on the quiz. Okay, so get in the habit now. Put a 1 before you start. Now, the reason we need to balance the reaction is because we have to be able to tell, looking at the reaction, how many of everything we need to make this reaction go properly. Okay, if we have way too much of this and not enough of this, the reaction won't go right. We won't get the right number of products. We can use the balanced reaction to figure out exactly how much of our two reactants we need to get a specific amount of whatever product. So the reaction has to be balanced properly. So now that we've put 1s in every blank, the second thing we're going to do is we are going to find the largest molecule, okay, the thing that has the most atoms in it. Well, this one has 4 atoms, this one has 3 atoms, this one has 5 atoms, and this one has 2 atoms. So 5 is going to be the one we're starting with. We are going to assume that this is actually going to stay a 1, because most of the time, at least a couple of these are not going to be 1s. There's 1 on the worksheet, I'll say, where everything is a 1, but there is only 1. Okay, so we are going to assume that this is actually going to be a 1 because it's the largest, it's the most likely to stay a 1. Notice I said most likely, not guaranteed, which is why I'm doing a separate video for combustion reactions. So we're going to assume this is going to be a 1. We're going to pick one of the 2 elements, either AS or S. Now, you're not here, so you don't get to provide any input. I'm going to do AS because arsenic is written first. How many arsenics are there right here? Well, there are 2, because 2 times 1, coefficient subscript, counting, 2 times 1 is 2. So there are 2 arsenics in this formula now, because we've put a 1 in front of it. So that's on the products side. We're going to find arsenic on the reactant side. It's right here. We need 2 arsenics on the reactant side. We only have 1 right now. Well, we can't change the subscript. You are not allowed to change subscripts. You can only change these coefficients. So we need to change this 1 into something that will give us 2 arsenics. Well, what times? There's already a 1 right here, right? This is a 1. It wasn't written, but there's a 1 here. So what times 1 gives us 2? Well, that would be 2. So now we have 2 times 1 for 2 arsenics. Our arsenics are now balanced. But that 2 did not just apply to that arsenic. That arsenic is attached to a chlorine. There were 3 chlorines. Now there are 6 because 3 times 2 is 6. So we need to find chlorine on the product side. It's right here. There's only 1 chlorine here. So what do we need to put here to take times the 1 that's not written to get 6? Well, we need a 6. So we're going to cross out the 1 and replace it with a 6. But once again, that 6 doesn't just apply to the chlorine, it also applies to the hydrogen. So we have to come back over to the reactant side and do the same thing here. We have 2 hydrogens here. 2 times 1 gives us 2. So we need to replace this with something that's going to give us 6 hydrogens. Well, what times 2 gives us 6? 3. So this has to be a 3. Okay, but again, that 3 doesn't just apply to the hydrogen, it also applies to the sulfur. There are 3 sulfurs here. So we come back to the product side. We find sulfur in our starting compound. And it is 3 already, because 3 times 1 is 3. So we are now balanced. We have 2 arsenics on both sides, 6 chlorines on both sides, 6 hydrogens on both sides, and 3 sulfurs on both sides. This is balancing. This is what we're trying to do. Okay, so I want you guys to try and balance the next 2 double replacement reactions. Okay, the other 2 double replacements, I don't have it in front of me, where is it? The other 2 double replacements, oh, there are 4 other double replacements. Don't try to do L or R. Okay, skip L or R for now. Skip L and R for now. So the other 2 double replacements are going to be, not L, P and I. So do P and I. Pause this, do that, and then I'm going to do single replacement. All right, now we're going to do single replacement. Same thing. It's the same process. We're going to start by putting 1s in every blank. So 1, 1, 1, 1. And we are going to find the largest molecule. Well, in this case, that has to be Fe3O4 because it's got a heck of a lot more than anything else. So this is probably actually going to stay a 1. I forgot to change my color. Let's do that. Okay, this is probably going to stay a 1. Now this time, though, you don't get to pick which one you want to do. You need to start with the one that is by itself on the other side. Okay, so Fe and O. O is part of water. Iron is by itself. So we're going to balance the iron first. Well, this is a 3. So over here, we need a 3. And with that, iron is now balanced. But we need to come back to this and now balance the oxygen. So here it's 4, here it's 1. So what can we put here to give us 4 oxygens? The 2 applies to the hydrogen, not the oxygen. So what times 1 gives us 4? Well, that's going to be 4. So this has to be a 4. Wow, let me try that again. Let's just do that. There, that's 4. Okay, so now we have 4 oxygens on both sides. But our hydrogen is no longer balanced. It was 2 and 2. Now it's 8 and 2. So what do we need here? We need another 4. And so now we're balanced. 3 iron, 8 hydrogen, 4 oxygen, 4 oxygen. And so we're done with C. Single replacement is just like double replacement is pretty straightforward, pretty easy. Composition and decomposition are a little more complicated. I'm going to make a separate video. I've just now, this second, decided for them. And then we'll do combustion in a third video. So we're going to stop here. Have a wonderful whatever, and I will see y'all next time.